Good day, engineers. Para sa video natin na to, ang i-discuss natin will be the sample problem number 2 for the analysis of T-beams. So sample problem number 2 states that a perimeter beam is monolithically casted to a 100 mm slab, and since this is monolithically casted, the 300 mm by 550 mm beam has an effective flange width of 550 mm. If this beam is to be analyzed at midspan, which is reinforced with 5 diameter 25 mm bars as tension reinforcement and diameter 10 mm as stirrups, determine the following if F prime C is 21 megapascal and Fy is 420 and the concrete clear cover is equal to 50 mm. So the first is the distance of the neutral axis of the reinforced concrete beam, and B, the ultimate moment capacity of the beam. So dito, in-state niya sa problem na that is a perimeter beam. So ibig sabihin, kung perimeter beam siya, ang sinasalo niya lang na slab is only one. It's either on its left side or on its right side kasi nasa perimeter siya ng structure natin. So probably for this type of perimeter beam, yung part siya na walang overhang. So for this beam, syempre ang magiging resulting beam natin kasama yung monolithically casted na slab will be an inverted L-shaped na beam. Especially kung hindi naman stated na meron siyang overhanging slab on the other side of our beam. So, ibig sabihin, kung yung main structure lang na slab sa loob nung building natin or nung structure natin, so, this will fall under the inverted L-shaped beam. So, before having the layout of our beam, we will first check kung paano natin or paano naka-layout yung 5 diameter 25 mm since hindi naka-state dun sa problem natin. So, for this part, we will check the spacing. So, i-check natin siya or i-try natin on a single layer, singly reinforced beam. So, for our spacing, we have here 300 minus yung clear cover na 50. So, 2 times 50 minus 6 na stirrups times 10. So, 6 times 10 yon. Minus, meron tayong 5 bar. So, that is 5 minus 1. And yung diameter ng bar natin is 25 mm. So, that is divided by n minus 1, which is 5 minus 1. So, from this calculation, we have S is equal to 10 mm. So, this is lesser than our 25 mm na minimum clear spacing. So, therefore, we have to try 2 layers of reinforcement. So, for the 2-layer reinforcement, we have here tatlong diameter 25 on our first layer. And we can have 2 diameter 25 mm on the second layer of reinforcement. So, let's check yung critical part, which is yung 3 diameter 25 mm bars. So, we have here S is equal to 300 minus dalawang clear cover na 50 minus 6 na diameter ng bar minus 3 minus 1 times 25 divided by 3 minus 1. So, we have here the spacing, which is 45 mm. And that is greater than 25 mm. Therefore, we have to use the 2-layer bars. So now, ang layout natin will be tatlong diameter 25 sa first layer and 2 diameter 25 sa second layer. So we can have this beam. So which is ito. So sabi doon, sa given natin, we have an effective width, effective flange width na siya of 550. So since sabi nga natin, ang resulting beam will be an inverted L shape. So ito yung 550. Then yung thickness nung slab natin or yung thickness ng flange natin is 100 mm kasi yung given. So that will be 100 mm. Ito siya. And yung normal beam natin or yung rectangular beam natin nung wala pa yung overhanging flange width, so that is 500 mm and the 300 mm. And ito na yung chinek natin na layout na 5 diameter 25 mm bars. So for now, we have to compute for other properties nitong beam na to, gaya ng AS, ng D at ng DT. So dito sa part na to, magkaiba yung D natin sa DT kasi 2 layers yung reinforcement natin. So start tayo on the part of the steel area, A sub S, which is equivalent to, that is 5 times pi over 4 times 25 squared. And it will give us a value 3125 over 4 pi. Then after getting the steel area of our beam, we will now proceed in getting the effective depth and DT. So sa pagkuha ng effective depth, syempre, kakailanganin na natin kunin yung centroid ng reinforcement para i-deduct or kasamang i-deduct dun sa height ng beam natin. So syempre, pupunta tayo on getting that centroid by using the Varignon's theorem. So syempre, kunin natin yung simple type lang nung beam natin or simple drawing. So here it is. So syempre, ang kukunin nating Y bar from the given will be ito. Nag-i-start siya dito sa bottom nung first layer reinforcement natin. And syempre, para makuha siya using Varignon's theorem, so proceed na tayo. We will have Y bar is now equivalent to, so area ng first layer reinforcement, so that is 3 times pi over 4 times 25 squared. Then yung centroid nun, so that is times 25 over 2 mula sa baba. So kasi ito yan, so that is just 25 over 2. Next, punta tayo dun sa side ng second layer. So that would be plus, so area muna, 2 times pi over 4 times 25 squared times yung centroid. So syempre, ang centroid niya is mula dito papunta dito. So we will have yung 25 over 2 na galing dito sa kalahati nito. So that is times 25 over 2. Then yung space in between the two layers, so that is just 25. Kasi yung main bars natin is 25. So syempre, ang gagamitin natin dyang spacer will be 25 mm. So that is plus 25. So minsan nilalagyan pa yan ng stirrups pa ulit dito, pa ganyan. So para may kapitan siya. So syempre, pag nilagyan mo na yan ng stirrups dyan, meron na yung additional na 10. So that is 10 plus 25 pa. So then, syempre, papunta sa baba, so yung diameter ng first layer, which is 25. Then we will divide that by yung total steel area natin, which is 3125 over 4 pi. So coming from this one, we could have the value of Y bar, which is equivalent to 65 over 2 mm. So meron na tayo ngayong Y bar. And now from this Y bar, we could get its effective depth. So the effective depth of our beam will be equivalent to 550 minus yung clear cover na 50 minus the diameter of stirrups which is 10 and minus the Y bar which is 65/2. So we could have a value of our effective depth which is 915/2 mm. And yung d sub t natin will be different from our effective depth. So si d sub t will just be the height which is 550 minus the clear cover which is 50 minus 10 minus the half of the first layer bar diameter which is 25/2. So that will result into a value equivalent to 955/2 mm. So ito na ngayon yung values natin nung AS, effective depth D, and nung DT. Now, after getting these properties, syempre, magpo-proceed na tayo on getting the concrete area for analysis at para malaman na din natin kung kailangan natin siyang i-analyze under a rectangular singly reinforced or an irregular shaped beam. So, to do that, syempre, we'll be using C is equal to T, and we have the compression side as 0.85 F prime CAC and the tension side as ASFY. So, ang goal natin is to get the concrete area for compression block, so that will be equal to ASFY times 0.85 of F prime C. So, our AS will just be equivalent to 3125/4 pi times 420 divided by 0.85 times the F prime C, which is 21. So the area of the concrete compression is 57,749.865. That is in millimeters squared. So that is the value of our concrete area. Now, to determine if our value or if our depth of compression block is within the thickness of the slab or magiging irregular shaped beam siya, so kailangan natin kunin yung area ng flange. And the area of the flange will correspond to the effective flange width multiplied by the thickness of the slab. So that will be 550 times 100. So that will be a value equivalent to 55,000 mm squared, which is lesser than our concrete area. Therefore, we can say that our A is greater than the thickness of the slab, and we will analyze an irregular shaped beam. So, yung beam natin will be analyzed as this one. So, it will be the type of beam na irregular shape kasi irregular yung depth of compression block niya. Siya yung hatch in blue. So, yan ngayon yung kailangan natin hanapin yung value ng A, and kailangan natin i-prove that steels are yielding since our initial assumption is the steels are yielding. So, for this one, we would get the stress diagram. So, syempre, this is our stress diagram, and since this is an inverted L beam or inverted L-shaped beam, so syempre, we will produce two diagrams din. So, ito siya, yung 550, and we have the thickness of the slab which is 100, and we also have this part which is the web part, and we have the 300 mm base of the web and the height which is A minus 100. So, To solve, we will have the gamitin natin yung equation na mahaba. So, pagsasamahin na natin yung CF and CW in a single equilibrium equation. So, hindi ko na siya paghiwalay na parts by parts kagaya nung ASF and ASW pa. So, we have here CF plus CW is equal to the T. So, the CF is etong part na to coming from the first diagram. So, that will be yung stress, which is 0.85 F prime C times the area BEH. Then, plus our CW will be 0.85 F prime C BW times A minus BH is equal to ASFY. So, next is transpose natin si 0.85 F prime C BH sa kabilang side ng equation. So, we can have 0.85 F prime C BW times A minus H is equal to ASFY minus 0.85 F prime C BEH. Then, after getting this one, we divide both sides by 0.85 F prime C BW. Parang matira na lang on the left side of the equation is A minus H. So, we have here A minus H. That is equal to ASFY minus 0.85 F prime C BEH divided by 0.85 F prime C BW. Now, we have here, simplify natin by just transposing the value H. So, we have A is equal now to ASFY minus 0.85 F prime C BEH divided by 0.85 F prime C BW. So, that will be added to the value H. So, now we have to substitute the values. So, we have here 3125 over 4 pi. So, that is the AS times the FY 420 minus, that is 0.85. F prime C is 21 times the effective flange width, which is 550, times the height of the flange, which is 100. That should be divided to the value 0.85 times 21 times the BW, which is 300. And we will add the thickness of the slab, which is 100. So, coming from this calculation, we can get the depth of compression block, which is A, and that is 109.1662. That is in mm. After we have get the depth of compression block, syempre, proceed tayo in getting the value of C, or the distance of the neutral axis from the extreme compression fiber. So, that will be C is equal to A over our beta 1. So, this comes from the NSAP equation. A is equal to beta 1C. So, we have here 109.1662 divided by 0.85. 0.85 yung beta 1 natin, since ang F prime C natin is 21. So, that is lesser than 28. So, we have here a value of C equivalent to 128.4308. That is in mm. So, now from this calculations, we will get, or we will verify if our assumption that the steels or the tension steel is yielding. So, we can get Fs is equal to 600 times D minus C over the C. So, that is 600 times 915 over 2 minus 128 128.4308 divided by 128.4308. So this steel stress will be equivalent to 1,537.3378, and that is in megapascal. And as you can see, this is greater than our yield strength Fy. Therefore, tama yung assumption natin that steels are yielding. So, we can say na yung unang hinahanap, which is yung distance of the neutral axis of the reinforced concrete beam, is we can say na ito na siya. Itong 128.4308. So, ito yung C natin. Since na-prove natin that steels are yielding. So, now we can proceed in getting the epsilon sub T for determining the reduction factor. So we have the equation epsilon sub T is equal to 0.003 dt minus C over C. So substituting the values on this equation, we have here 0.003. Yung dt natin will be 955 over 2 minus 128.4308 divided by 128.4308. So having the values from this calculation, we have a value for epsilon sub t, which is equal to 0.008 154, which is greater than the value 0.005, and we can conclude that this beam is ductile, and we have a reduction factor equivalent to 0.9. So now we are ready to determine the nominal moment capacity of our beam. So kunin natin yung stress diagram, which has the moment arm. So, from these diagrams, we would get the values of the moment coming from this flange section or the first diagram, and the moment coming from the web section, which is the second diagram. So, from our moment for the flange section, which is equivalent to the compression of the flange section times D minus H over 2. So, syempre, gagamitin natin yung mga compression side kasi hindi naman na tayo kumuha ng value ng ASF and ASW. So, the moment arm is D minus H over 2 since yung height neto is the value H or yung 100 mm na thickness ng slab. So, our CF will be equivalent to 0.85 F prime C BEH times D minus H over 2. Substituting the values, we have here 0.85 times 21 times 550 na effective flange width times 100 times 915 over 2, which is the D, minus H, which is 100 divided by 2. This shall be multiplied by 1 over 1,000 squared para maging kilonewton meter. So, calculating these values, we will have the moment for our flange section, which is equal to a value 400.0631. This is in kilonewton meter. Now, we can proceed to the second diagram. So, kunin natin yung moment sa kanya, which is for the web section. So, that will be M sub W is equal to CW times D minus A plus H over 2. Kasi, same lang to nung nasa T section na ginagawa natin or yung dinerive natin from the previous videos. So, kailangan natin ng D, tapos ima-minus mo yung H. Siyempre, kukunin din natin yung kalahati ng A minus H. So, that is D minus H minus A minus H over 2. So, as you can see, that is D minus H minus A over 2 plus H over 2. So, negative H plus H over 2. So, that is D minus A over 2 minus H over 2. So, as you can see, ito na yung simplified form niya. So, that should be multiplied by that is our moment arm. So, yung CW natin dyan, that is 0.85 F prime C BW times A minus H times D minus A plus H over 2. So, ito na ngayon yung ating moment equation for the web section. So, substituting the values, we have here 0.85 times, so that is times 21 times yung BW na 300 times yung A minus H. So, A is 109.1662 minus H is 100 times yung D natin, which is 915 over 2 minus yung 109.1662 plus H is 100 divided by 2. So, this whole equation still shall be multiplied by 1 over 1,000 squared para maging kilonewton meter. And the MW for this web section or the moment on the web section is 17.3229. That is in kilonewton meter. So, ito na ngayon yung moment on our web section. So, to have the total nominal moment capacity ng beam natin or yung irregular shape na beam, so we have here Mn is equal to the value of the flange section or the moment of the flange section plus the moment of our web section. So, adding those two values, we have here Mn is equal to 417.386. So, that will be in kilonewton meter. So, now to get our ultimate moment capacity, so that is Mu, we will have here phi Mn. So, that is just 0.9 times the nominal moment capacity, which is 417.386 kilonewton meter. So, calculating that equation, we have the ultimate moment capacity of our irregular shape beam, which is 375.6474 kilonewton meter. Ito na ngayon yung ultimate moment capacity nung ating beam. So, yan ay hinahanap natin from our problem. As an additional to this sample problem, check na rin natin yung mga balance still ratio niya and yung maximum still ratio as well as yung minimum still ratio. So, for the balance still ratio, syempre, ang gagawin natin dito is kunin natin muna yung C balance niya. So, first, kunin natin yung epsilon y. Si epsilon y kasi, siya yung kailangan natin dun sa equation ni C balance. So, that is Fy over 200,000. So, Fy natin is 420 divided by the value 200,000. So, our epsilon y will be equivalent to 0.0021. Then, calculating yung C balance natin, that is equal to 0.003 over 0.003 plus epsilon y times the value d. So that will just be 0.003 divided by 0.003 plus 0.0021 times the effective depth, which is 915 over 2. So our C balance will just be equivalent to a value 4,575 over 17 mm. And that is our C balance. Ngayon, to get our raw balance, syempre dadaan ulit tayo dun sa paggamit ng diagram na to. So, kunin lang din natin. Pero ang gagamitin natin dyan na A is balance na A. So, that will be CF plus CW is equal to T. Yung CF natin, that is 0.85 F prime C BEH plus we have here sa CW will be 0.85 F prime C A balance, syempre balance condition yung kailangan natin, minus H is equal to AS balance FY. So from this given, yung AS balance natin dyan is equivalent syempre sa raw balance BWD. BW kasi yung C na itong irregular shape beam na to is tumama sa BW natin. And yung A balance natin syempre, that is still beta 1 C balance. So substituting, we can have 0.85 F prime C BEH plus 0.85 F prime C, that is beta 1 C balance minus H is equal to raw balance BWD FY. Then calculating the value for raw balance, so yung BWD FY will be divided on both sides. So para maging raw balance na lang is equal to 0.85 F prime C BEH plus 0.85 F prime C beta 1 C balance minus H over BWD FY. Ito na yung equation natin. So we can substitute. So to substitute, that is equal to 0.85 times 21 times our BE, which is 550, times the H, which is 100, plus 0.85 times 21 times yung beta 1 C balance natin, which is, yung beta 1 natin is 0.85 times yung calculated C balance natin, which is 4,575 over 17. Then that will be minus 100. So divided by, that is BWD, so 300 times D is 915 over 2, and our FY is 420. So calculating our raw balance, we have here 0.028991. Ito ngayon yung ating balance steel ratio. Now dako tayo dun sa maximum steel ratio. So sa maximum steel ratio natin, syempre kukuha muna tayo ng Cmax, and probably will arrive with the same equations as this one. So ang maiiba lang is yung Cmax kasi natin is on the part of the 3/8. So ito magiging for the maximum steel ratio, kasi same derivation lang sila as above nitong balance steel ratio. So probably we will arrive with the same equation. Ang mapapalitan lang itong part nito na beta 1 C balance, magiging beta 1 C max yan. So we will have here yung C max muna kunin natin. So from the previous videos, we have 3/8 of DT yan. So calculating that we have 3/8 times 955 over 2, and we have a value CE max equivalent to 2865 over 16. So this is in mm. Then yung part ng raw max natin, hindi ko na i-derive kasi this is just the same derivation as this one. Ang mag-iiba lang yung beta 1C balance nga at magiging beta 1C max yan. So our raw max is just equivalent to 0.85 F prime C BEH plus 0.85 F prime C, that is beta 1C max minus H over BW dFy. So that will be equal to 0.85 times 21 times BE is 550 times 100 plus, so 0.85 times 21 times yung beta 1 natin is 0.85 times C max is 2865 over 16 minus H is 100. So that should be divided by BW dFy. So that is BW is 300 times 915 over 2 na D times Fy is 420. So our raw max coming from this equation will be 0.02188. So to check, pwede natin siyang i-verify sa raw actual at makikita natin na hindi naman siya magdodobli. So yung raw actual natin will just be AS over BD or BWD. Kasi nga, nandun na tayo sa part ng BW. So that will be, ang AS natin is 3125 over 4 pi, tama ba? So that is 3125 over 4 pi. So that will be 3125 over 4 pi. That should be divided by BW, that is 300 times 915 over 2. So our raw actual will just be equivalent to 0.017882, which is, as you can see, that is lesser than the raw max and also lesser than our raw balance. So ibig sabihin, hindi naman siya over-reinforced and hindi siya magdodobly reinforced kasi singly lang siya. And also, if we will get raw minimum, si raw minimum ang mag-govern dito will be 1.4 over Fy. Kasi kunin natin yung code. Kasi sa code provision niya ito. So same code provision as a rectangular singly, ang gagamitin natin is yung BWD. Pero this is, remember, ang sinabi dito is AS min. So that is a value na yung sinabi natin from the start para makuha si raw minimum, that is AS min over BWD, which is same pa rin kung ang gagawin natin is raw minimum lang. So yung raw minimum, tanggalin lang natin yung BWD, yan na 1.4 over Fy, kasi nga yung F prime C natin, ang magagamit natin dito is 1.4 over Fy kasi nga yung F prime C natin lesser than 31.36 megapascal, which is na-derive naman natin to from our previous video. So from this one, we can check kung papasok yung equation natin or yung raw minimum natin. So that is 1.4 over 420. So we have here a value for this calculation as 1 over 300, or this is 0.003333, and that is lesser yung raw actual natin dyan, or mas malaki pala yung raw actual natin dyan. So ibig sabihin, sumusunod or nagko-comply yung irregular shape beam natin on these provisions of our code. And as you can see, malaki yung pinagkaiba ng Romax nito from the Romax ng rectangular singly. Kasi sa rectangular singly, ganito lang yan. So, pag rectangular singly, yung Romax doon is 3/8 ng 0.85 f prime c beta 1 over fy times dt over d. So, kung ikakalculate natin sa kanya dito, makikita niya na mas mataas yung value nito. So, that is rho max is equal to 3/8 times 0.85 times 21 times 0.85 times fy is 420 times yung dt niya, which is 955 over 2 divided by 915 over 2. From this calculation, yung rho max for a rectangular singly reinforced is 0.014. That is 0.01413. So, as you can see, mas malaki yung rho max ng irregular shape beam compared to a rectangular shape singly reinforced beam. So I think that will be all for this video on sample problem number 2, and that will be the last sample problem for the analysis of T-beams. Again, this is Engineer Rodolfo. Thank you for watching, and don't forget to subscribe to Butch TV.